There are many ways to characterize data, such as structured or unstructured, persistent or ephemeral. This lesson focuses on characterizing data based on what the user cares about. Most often, the user doesn't care about the underlying technology, but about whether the data is accessible when they need it, and whether the data they retrieve is the same data they stored and not modified or altered.
So here we go, classifying and characterizing data. So what users really care about is data integrity. They can't really distinguish the difference between data loss, data corruption, extended unavailability. If their data is not there, it might as well be gone. However, as an engineer, persistence and access are very separate. Access basically is a loss of data access is very important to users, but that doesn't mean that their data is gone. Persistence and proactive detection and rapid recovery is really what our goal is. If there is data that is somehow lost, we want to be able to get it back, recover it, maybe using version controls or backups or some kind of failover mechanism. So when you're thinking about your data, you need to think about what data transaction properties are going to be required. And of course, you have your menu, and you can only really pick two, and this is the CAP theorem. So here you have to choose between consistency, availability, and partition tolerance. Well, in this case here, if you want availability and partition tolerance, you can go over to base, which is basically available storage. It's soft state, and it's going to be eventual consistency. Now, what that means is you may make an update. It may not be available there immediately, or specific changes may not necessarily be available. But with that type of ability, it allows you to write data, allows you to expand your data very, very quickly. And eventually, everything will all be consistent. Now, if you want pure consistency, then we get into what we call ACID transactions, which stand for atomicity, consistency, isolation, and durability. That means if you write some data to your data storage system, it is guaranteed to be there. You will not get an acknowledgement until it has been written and it is completely fault tolerant, replicated, etc. So it will ensure any type of failover capabilities. And so there's a big difference between these two, and we'll be able to discuss we'll discuss internally exactly which might be the best use case. So in this case, let's ask ourselves, what are the data consistency requirements? What if we choose Google Cloud Storage? Now, if you look at GCS, you get a lot of consistent capabilities. Read after write, read after metadata update, read after delete. So if you delete it, it's instantly gone. If you've uploaded, you'll instantly get to the list of it. Anytime you list the actual items in the bucket, those are guaranteed. That is the exact list as of the time of that request. Now, eventual consistency has to do with versioning. So depending on how long we overwrite, if there were changes that were made and versioning is enabled. What if we want to decline access? We're not deleting the file. We just want to change the privileges on that. Now, that is a wide distribution mechanism that has to occur all throughout Google to make sure that all of our security tables are updated, and that could take a little bit of time. Also, caching an object does not show strong consistency because you could definitely have an older version in cache. That's kind of the trade-off with cache. With cache, you get that consistency and low performance, but then again, it may not be the most up-to-date copy. So when you look at what you're trying to optimize, you want to be able to choose a specific service that depends on which requirements that you want to focus on. So are you focusing on uptime? And uptime is essentially, how often is it going to be available and accessible to the user? They want to make sure that if they access their data, then it's going to be immediately available. Otherwise, it's very quickly going to be available after a retry. So think about uptime when it comes to banks, right? Your bank, for example, it's open during certain business hours. Now, you may try to get access to your money or your funds after hours, but it's closed. It doesn't mean that your data is not available. It's just, there's a different uptime availability for banking. What about latency? This is how quick your data can get back to your users. If you have images and static data on a website, you want to make sure that it appears quick because our attention span really doesn't last very long. Scale, how large will it grow? And velocity, how fast will it potentially grow? Can we really scale this out on the fly, or is it going to cause some serious re-architecting once we hit certain thresholds? And what about privacy? So we need to ensure that data is destroyed after a reasonable amount of time. There's the recycle bin, but after it leaves there, do we want other mechanisms that will allow us to recover it, but also ensure that it never comes back?